So in this question, we have another force time graph. So we'll do our Oizerga. Origin is up here. And we're dealing with negative forces. So we know where the origin is. The y-axis is force, x-axis is time. The intercept, yes, we have a y-intercept at 0, 0. And we also have an x-intercept where at 0.5 seconds, the force is 0. Well, we read the axes, force and time. The gradient is dividing the axes, delta F over delta T, which is the rate of change in force, which we can see is a constant negative rate of change, and then we have a constant positive change. And the area is F times delta T, which we recognize as the impulse. And the impulse, F delta T, is equal to the change in momentum, which is mass times change in velocity. So we have our four-way equivalence. So we've broken this thing down. We are ready to go with this question. So we have a block of mass 10. So we'll draw this out. We have a block of mass 10 kilograms, positive direction on the surface with no friction. The block has an initial momentum of 18 kilogram meters per second. Well, if momentum is mv, we have a mass of 10 and the momentum is 18, then the velocity is 18 over 10, or 1.8 meters per second. That's just something we know. It collides with an object of unknown mass that is at rest. So here is the object. Its velocity is 0. The force exerted on the block as a function of time is shown on the graph. So this object is going to exert a force, a negative directed force. And so we're going to need to predict the speed and direction of the block immediately after the collision. So we can see when this thing, like sliding along the way, and it hits a bump or bumps into something, we would expect it to either slow down or bounce back. Or I suppose it could stop. So the force exerted is shown on the graph. Which of the best predicts the speed and direction of the block immediately after the collision? So let's examine this. If we want to know the change in momentum, we know the initial momentum, we would find the area. And so the area then, since we have an F max of 50, that means the average of the F max and the initial force would be 25. So we have a minus 25 times 0.5 is 12.5, negative 12.5 kilogram meters per second. So we have 18 kilogram meters per second. It receives an impulse of minus 12.5 kilogram meters per second. So we could see then is the initial momentum wins out, and we end up with a net momentum afterward of 5.5 kilogram meters per second. So what we know is it's going to be the same direction. So that allows us to take out choices C and D. And we know the speed is going to decrease. It has less momentum than it did before, and that's why it's choice B.